Okay, today's lesson is 117, significant digits. What's our objective, class? Get ready?
Significant digits.
Significant digits. Today you're going to learn how to determine how many significant digits a number has. You will learn to apply the rules for operations with significant digits to determine the number of significant digits that should appear in the answer. That's a lot of words. We're going to talk about basically precision. So, and that's how significant digits relates. This ruler has an amount of precision based on how close I can measure something. So if this is between 8 and 9, this is a centimeter ruler. This is 8 centimeters, 9 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 0.9. So I could say this is 8.9 centimeters. But what I couldn't say is this is 8.88 centimeters because I don't have enough precision in that. So the most accurate I could do is 2 significant digits in here. Or I could call this has got a significant digit of 2 because there are 2 values. It would make sense to say 8.916, and really 9 is too vague because I had enough accuracy to say 8.9. So the number of digits we use to express a measure with confidence is called the number of significant digits. What is it called? Get ready.
Number of significant digits.
Very good. So we said that 8.9 has 2 significant digits. There are some rules, and I will pass out a little handout that has all these on here. But we're going to go over these and then do a couple of sample problems. All right, this number has 1, 2, 3 significant digits. They're non-zero, and we're going to count all of them. So 3 significant digits. How many? Get ready?
3.
Good. This one, actually, there's special rules about zeros. But if the 0 is between 2 non-zero digits, you do count it. So this has 3 significant digits. How many? Get ready?
3 significant digits.
3. This one, even though there's a 0 on the end and we say, hey, the 0 doesn't change its value, it's really 1.2, you do count it as a number of precision because someone might have wanted to signify that it wasn't 1.19 and it wasn't 1.21, but I know of an accuracy, it's exactly 1.20, and because they've included the 0 in the measurement, they're trying to make that as accurate as possible. So we would call this 3 significant digits. How many? Get ready?
3.
3. If, this is a weird one, so you just have to memorize this one. It's just a rule. If it's a decimal number and there's zeros before non-zero numbers, they don't count the zeros. So this actually only has 2 significant digits. How many? Get ready?
2.
2. If you've got a whole number that ends with 0, so like 1200 or maybe 4000, that gets a little bit ambiguous. And so they said if you can put it into a scientific number like this, then we could say, oh, okay, that has 1, 2, 3 significant digits. How many? Get ready?
1, 2,
3. 3 significant digits. Okay. And then our last rule is for exact numbers. What's an exact number? An exact number would be like there are 12 inches in 1 foot. That's a known thing, so I wouldn't say how accurate is 12. Is that pretty precise? That's just a known given fact. There are 3 yards in a foot. 3 feet. 1 yard is 3 feet. Okay. Oh, there's 5,280 feet in 1 mile. So if that happens and they say how many significant digits, you say, it's not applicable because that's an exact number. So you say NA exact number. What do we say? Get ready?
NA exact number.
Good. NA exact number. So let's quiz and see how well you listened for the first part of our lesson. I'm going to pass out the flyer. You want to hit pause on that? Okay. So let's quiz to see how well you understand significant digits so far. Part 1. The diameter of a quarter is about 2.5 centimeters. How many significant digits is that? I'm going to call on you. Is it going?
Yeah.
Okay. Michelle. It's an exact, these are all kind of abouts. So someone measured it and they're pretty sure. 2 digits is correct. Part Part B, a ruler is about 30.5 centimeters long. How many significant digits does that have? Hannah? 3 is correct. Very good. 1, 2, 3. The Earth's average distance from the Sun is about 9.3 times 10 to the 7th. How many significant digits does that have? Layla? 2. Wow, you guys listen the best out of all my classes so far. Part D, a mile is exactly 5,250 feet. How precise is that? Spencer?
It's not applicable to an exact number.
Not applicable. It's an exact number. You guys got it. Awesome. Okay, next part of our lesson is we're going to talk about what do we do when we take two measurements. Maybe you're a carpenter and you're adding a measurement to another measurement, or you're an engineer. Let's talk about multiplying and dividing. It's on the bottom of your handout in the first box that's on your handout. It says a product or quotient of two measurements may only have as many significant digits as the measure with the least number of significant digits. Which means if I took maybe it's a board, it's 8.9 centimeters. Okay, that's not a board, that's pretty small. But I need to divide it into 4 equal parts, and I'm going to do a quick division. 2, 8, 0, bring down my 9, 2, 8, 1, throw a 0, and 4 into 10 goes 2, 2, 8, 2, bring down a 0, 5, okay, so 2.225. This rule says whatever measurement you start with, the least number of significant digits. I have 1, 2 significant digits. My answer can only have 2 significant digits. So what I do is I cross them off. 2.25. So my final answer would be 2.2 centimeters. Some of you are going, wait, what about the 4? It's not a measurement. I just was dividing it into 4 parts. It's not 4 centimeters, just 4 parts, okay? So 2 significant digits, my answer has to have 2. What if my final answer was 2.26 centimeters and I was supposed to get rid of this one? The rule is round your last digit. What's the rule? Get ready?
Round your last digit.
Round your last digit. So I would have to round this one up to 3. So I would say 2.3 centimeters. So again, 2 significant, answer 2 significant. Okay, the next rule in the box says, a sum or difference may show no more decimal places than the measurement with the fewest number of decimals. Would you take your pencil and put a box around decimal places? This is different than significant digits. This time you don't count all the digits. You just count how many decimal places there are. What do we count? Get ready?
Decimal places.
Decimal places. So in this question it says the test tube contained 6.24 milliliters of liquid before it was heated and 4.6 milliliters after it was heated. How many milliliters of liquid evaporated? So we're going to do a subtraction. All right. Now notice I have 2 decimal places and 1 decimal place. According to the rule, it says my answer can't show more decimal places than the measurement with the fewest. So I know I'm going to have 1 decimal place. Be careful. I had so many students that confused. They were trying to count, oh, there's 3 digits here. But there's only 2 decimal places, okay? It's big star, star, it's decimal places. 2 decimal places, 1 decimal place. Let's subtract. So 4 minus 0 is 4. 2 we're going to have to borrow. 6, bring down our decimal, and 1. How many decimal places do I have? Think. Get ready?
2.
2. How many do I need to put in my answer? Is it 2 or 1? Get ready?
1.
1. So I'm going to just cross it off, and I'm going to rewrite 1.6. What would I do if that was a 8? Hannah? Yeah, so what would it become? A 7. Okay? All right, Jasmine.
I'm just curious, when do we know not to use these rules? Because sometimes it's
You're like, we have all year we've been working with measurements and numbers and we never cared about this, right? This is like the only lesson that it matters in. Okay?
Really?
If you see it on the RICE test, which I'll be honest, I don't think I've seen it on the RICE test yet. I've walked around and I don't think I've seen this question, but only do this if it says significant digits in the question. Okay? It'll say the word significant digits or the correct number of digits for the precision. It'll have the wording in there so you'll know. Otherwise, just do it how you've done it all year. Okay, we are on page 766. Take a stand-up break.